Jó napot kívánok! Welcome to Innovation, a bridge to a sustainable gas future, the official IGRC2027 Budapest podcast, a show where we talk about the current state and the future of a global and sustainable natural gas industry. We give you a universal perspective of the gaseous energy sector, leading practices, new trends, and traditional solutions, industry insights, and new investments which will shape our future. Please don't forget to follow us on LinkedIn, Spotify, YouTube, or wherever you get your podcast. Enjoy the show. Dear ladies and gentlemen, welcome to the fourth episode of IGRC 2027 podcast series. My name is Tamás Plecser. I'm Erste's oil and gas analyst. For those who might be not familiar what IGRC mean, it is the abbreviation for the International Gas Research Conference. International Gas Research Conference, or IGRC 2027, will take place in Budapest, Hungary in May 2027. This crucial and important event will be organized by MVM Synergy, Central and Eastern Europe's leading gas and power company. MVM is the member of the International Gas Union, or IGU, the largest global association of natural gas companies. IGU is running the IGRC conference series. The International Gas Research Conference takes place every third year in selected venues worldwide. Our distinguished guest today is Dr. Zsófia Bíró, a space policy expert and a distinguished lawyer specialized in energy and finance. Zsófia is currently working for the University of Pécs, a city in southwest of Hungary, where she is teaching, making research and advisory work in the area of innovation and technology, energy law, sustainability and economy. We talk today with Zsófia about her favorite topic and the area of competence and interest, the outer space, law and energy. Or by other words, why and how the humankind can conquer space, and what are the key energy and legal challenges in these efforts. So Zsófia, welcome to our show.
Thank you so much, Tamás, for the kind introduction. It's a real pleasure to be here. When we look up at the night sky, most of us see stars, but some of us see infrastructure, strategy, and investment potential. Outer space is no longer just a domain of science fiction or post-Cold War rivalry. It has become one of the most dynamic areas of innovation, economy, and geopolitics. What used to be a race between nations is now real between governments and private actors. And what may the future hold, I think we are going to have a nice conversation about.
Yeah, I really hope so. I'm very interested in your knowledge because I know that you are a real great expert in the space. Tell me one thing at the beginning. Why the humankind is interested in space? What do we want here? Why we are interested in space travel?
It's because space is the ultimate mirror. It reflects on our deepest aspirations, maybe survival, curiosity mainly, dominance and legacy, I would say. And conquering space is not just about planting flags or building Mars colonies, it's also about solving problems down here on Earth, and this is the most important aspect. So space helps us monitor climate change, optimize agriculture, secure communication, and even reimagine how we can use energy.
Okay, so you mean that conquering space is not only for itself, but it has some positive advantages to the human life on Earth itself.
Of course, this was the original plan. That's why we went out there and tried to, maybe we can say that, reinvent ourselves and humanity.
You have a strong background in law, as far as I know. And tell me, what are the legal frameworks which regulate the space travel? I mean, how can I, as a private company or a nation, send ships to the space? What are the legal background here?
So when it comes to the legal part, there are 5 main space-related treaties. I would highlight the Outer Space Treaty from 1967. And this is the most important one, even in our case, because it regulates that nations party in that treaty, how they have to cooperate in space and what can they use, which belongs to each other. But we can mention the Liability Convention, the Registration Convention, the Moon Agreement, but maybe for today's talk, the most important is, the other most important is the Artemis Accords, which is not a legal document, but more than like a policy paper. But this is what contains the utilization of space resources and energy resources belongs there.
Are the major nations divide the space between themselves, or is it like a common good?
It's absolutely a common good. It prohibited the sovereign appropriation of space, and it is stated in the Outer Space Treaty that space is the common heritage of humanity.
Okay, but how can I imagine if I want to send a satellite and it probably has a certain orbit, right? What kind of orbit can I use? Is there any agreement on that? Or is there any share of this resource?
Yes, of course, there is. Here comes the Registration and Liability Convention into the picture. Every time when a nation would like to launch a rocket into space, it's required state authorization. And the state who authorized the launch bears responsibility for the space activities belonging to that space flight.
Okay, and who can regulate if there is a conflict over here?
It usually belongs to the table of the UN and the COPUS, which is the so I wanted to say it so fast. So the Committee on Peaceful Uses of Outer Space. And this is where it belongs, or they can also have some kind of diplomacy way to apply, and of course they can sue each other, but that never happened until yet.
Okay, were there any cases of these conflicts in the past? Do you know any time when, for example, Russia or the US had some conflict that I want to use this orbit, I want to use this space?
No, with orbits. There was one serious case, but diplomacy solved the issue when a Russian or a Soviet satellite fall down onto Canadian areas, and it used RTG technology, which is nuclear, and there was a radiation on the special areas of Canada, and Russia had to clean it up and pay a special amount of fee, but that was all.
Okay, I see. What are the major latest developments? I mean, we hear a lot about private launching. We hear a lot about new initiatives, new solutions. Can you tell me the most important issues which are in the press or which are, driving now this whole process in conquering the space?
Yeah, first of all, I would like to note some obvious ones that we can meet on first sight on the internet, and then we can go into much more interesting examples. So there's basic Starship, which is the greatest rocket and Starship we ever had at the moment. It's reusable and it's a high-capacity spacecraft. But Blue Origin also develops a rocket, and Rocket Lab has its own version. These are, I would say, the pioneers of rocket building at the moment. There's the Artemis program, which would like to send human to the moon again and build also presence over there. But of course, as we have AI over here, we use AI in the outer space as well, which helps maneuvering, fall detection, data processing, and big data is also a thing in outer space as well. We are going to have a new space station built by VAST, from California, and they will also apply AI on board. And when it comes to my colleague said, and once I gave a presentation about these topics, and they said, okay, it's science fiction, it's 30 years away, and I told them, no, go search, not. So go 2,000 kilometers west, and it is happening right now, because, for example, in Luxembourg, there are space mining companies. They are existing, and in other 3 countries at the moment, as far as I know. And they are going for space resource utilization. We can mention the moon or asteroids or any kind of space resource utilization. And when it comes to energy, there are plans to build big solar constellations on Earth's orbit. And if we think about it, it was the plan in science fiction literature back in the 1920s. And now it's coming to life. So I recommend to take a look at today's science fiction, and maybe we can see the future within 50 years.
I see. And are these initiatives driven by private companies like Elon Musk's space company, or is it more like a public financed initiatives? And also, if you can tell a little bit more about these efforts, I mean, what are the purposes? I know about the space travel. I've heard about that. I know we talked a lot about mining in the space and also the energy, what you mentioned recently. So can you tell us more about these initiatives?
Yeah, so first of all, the first space race was strictly nation-based, and it was a public thing. No private companies could take part because of financial issues and because of lack of knowledge. But from the 2010 and on, when Elon Musk launched successfully the reusable rocket, we can say that was the beginning of the second space race. And it proved that private companies are game changers and are in the game. For example, now we are working on a model like how public-private partnerships can work out in space, and they really would like to cooperate. So we see that, for example, NASA write out tenders for private companies. NASA has different goals, and companies apply and cooperate with them to make it happen. So they kind of outsourcing it, we can say this way. And that's what the future holds, I think. So we are going to have common strategies. Nations always be involved in strategy building, but it seems like that within the next 30 years, private companies will take over.
Out of the current purposes, what do you think, which one will be dominating in the future? The space tourism, simply acquiring knowledge about the space, energy issues, or mining issues? So what do you think out of these? What will be the dominant force?
As here down on Earth we have different aspects of life, it is also true for space. It seems like that, first of all, it was like a marketing reason. We remember that Elon Musk launched the Tesla into space. Of course, it was a really hard marketing message. But after that, when nations realized that what kind of safety and security issues are behind the new space race, now I would say that on international level, the most important is the defense part of the space. But as we already touched this part, private money is needed to this new space era. And that's why also the space tourism, which is a way we cannot leave out the scientific part, because that bring us forward. So scientific is the scientific part always go hand in hand in any other area in space, because the innovation and development always began with science.
I see. While we were preparing, you mentioned the case with helium-3.
Yeah.
Can you tell us a little bit, because I think this is such a fascinating story. I was really, fascinated by hearing that, why we need helium-3 and why we may mine this material on the moon, which seems to me a science fiction. I mean, for me, that would be such a high cost and such a high effort that I don't understand why we don't look for this material in the Earth. So why helium-3 and why moon?
So I think, first of all, France tried to make a stable fusion power reactor here down on Earth. Now, if I'm right, China and Japan are also on these ways. We will see. But fusion power works with tritium and deuterium kind of fueling. But tritium is really rare.
Which is actually a hydrogen, as far as I know, hydrogen isotopes, right?
Yes. It's really rare in terrestrial ways. But not long ago, China and the US realized that on the surface of the moon, there's the so-called regolith, and the sun wind during millions of years put down the helium-3 isotope on the surface of the regolith. And approximately there is 1 million ton of helium-3 over there. And if we would be able to utilize that helium-3 and bring down back on Earth, it's it also can be used instead of tritium, and it, for example, 20 to 25 tons of helium-3 would be enough to supply the whole electricity demand of the US for 1 year.
Oh, okay.
With stable fusion power energy.
Assuming that we have fusion power plants and we can supply with the electric grid from fusion.
Yes.
Okay. Very, very fascinating. There was nothing, I mean, I wouldn't think about that, but how you say this, this looks to me really a very interesting option. And if there is such a high abundance of helium on moon, I can easily imagine that, yeah, maybe to go there and take the helium from moon back to Earth makes sense.
And imagine how much other elements we have over there. We haven't conquered yet, haven't realized. And later on, when we are going to have a moon base, or at least a lunar gateway around the moon, I think much more interesting secret will turn out.
Okay. As we are preparing for a gas conference, and we talked already about the gas, different types of gas which might be used in space travel, can you tell me a little bit about the opportunity and the usage of methane? I mean, you mentioned to me already that methane can play a crucial role in space travel. So what were the traditional fuel for the spaceships, and why methane can be an important fuel for the future, and how can we think about this in the future? So what kind of a methane demand could it mean if space travel becomes widespread?
Yeah, so the conventional fuels, we can say that these were usually the kerosene and the hydrogen and some kind of mixture of these, and liquid oxygen and so on. But of course, who else? Then Elon Musk invented that, okay, the big rocket, the Starship, can go by methane. He tried and he succeeded. So nowadays there is Blue Origin, Rocket Lab, New Glenn, and many others who also developing these kind of methane-based rockets. And they choose methane because it's more stable than hydrogen, and it's easier to store. It requires less cooling and allowing longer storage times. You remember when Tibor Kapu, the first launch attempt was, and before the first launch attempt, they realized, okay, we have some gas issues with the rocket. So that's why maybe there's less probability when we use methane for a rocket.
Is this methane in the form of LNG or compressed natural gas? And do we need to carry the oxygen besides the fossil part of the fuel?
Yeah, it's LNG. For example, the SpaceX Starship, the Super Heavy and the Starship upper stage together uses approximately 1,000 tons of liquid methane in the form of LNG. And this is closely equivalent to 1.4 million cubic meters of methane in gaseous form at standard pressure and temperature. And additionally, they use 4,000 tons of liquid oxygen called LOX, and it's the type of oxidizer they have in the rocket.
You mentioned several aspects why methane is more advantageous compared to the traditional fuel what spaceships were using. Why in the past methane has not emerged? Was there any reason for that?
I would say, give a parallel to this, like the shale gas in the US, because we didn't have the technology and it was too expensive to do that. But now SpaceX has its own LNG station as well. There are some disadvantages regarding methane. For example, it has lower energy density or require a larger tank volume than kerosene did. At the moment, it is technologically less proven in large-scale space flights, but it seems like that overall it's a promising future fuel because it can be in situ resource utilized on the surface of Mars as well.
What is the consumption rate of an average launch, spaceship launch? I mean, how much methane do we need to use if we want to send one spaceship to the space?
Approximately 1,000 tons of liquid methane is needed, but Elon Musk's plan is to have, it's a long-term goal of SpaceX to have daily launches. He set a really ambitious goal that he would like to have approximately 10 launches daily. I would say not that in the near future, but I can imagine that within our lives there can be in one day, one launch per day or per 2 days, we will see. But if we would accept his theory and to have 10 launches daily, that would mean that it requires 10,000 tons of methane per day. It's around 14 million cubic meters of natural gas, and it annually this would amount to 3.65 million tons of methane, and it is equal about 1 to 2% of current US industrial LNG demand. So I won't say that there will be a peak on the methane market, but if all the other spacefaring nations would start to use methane, that can be a big step on the long run.
Okay, so it means that 2-3% of our methane use can be the addition demand due to the space travel, if the space travel is widespreading, or if
Yes.
space travel is like
Exactly.
an everyday event. Well, I would say it's probably not so much, but it's already substantial compared to the current usage. Do you think that methane will be the winner here, or is there any other alternatives how we can send spaceships to the space?
I would say there is similar to terrestrial travel, like we had the conventional fuels, we still have them, but we have electric cars as well. So I would say we will see how the space sector develops itself, what new thing maybe they find on the moon or other celestial bodies. But at the moment, it seems like that for the next 20 years, methane will be the first of these fuels.
Outside of methane, or do you see, sorry, do you see the methane as the major fuel for the space shift itself when it is in operation, or do we have any other energy sources like photovoltaic cells or nuclear energy or any other solutions?
You mean by space flights?
Yes, I mean when we already have the spaceship, the space aircraft in the space to supply energy for this travel further on, to keep the life on the space shift or to mine electricity. So do you see this? Do you see the methane as to play also a key role, or do we have any other alternative solutions which might be more efficient or suiting better for these efforts?
So when we have to cope with the gravity, then this is the point when we need the methane. But when we are in outer space and in microgravity environment, then after that, it depends on the kind of mission. If it's because on the kind of the mission and on the distance from Earth or from the Sun. Because like on short missions, for example, on orbital level around Earth is usually chemical energy production, so no rechargeable batteries. But if we go on a longer way, then photovoltaics is on the first. So solar panels are on are the first on the list, and usually with rechargeable batteries. But when it comes to longer travels, even I think to the moon, it will be within short amount of time the solution. And for Mars, for sure, we are in need of the nuclear solutions. Now we have this RTG, which is the radioisotope thermoelectric generators, like they use the decay heat of the isotopes. But on the long run, and there's a big lobby in the US right now that fission reactors would be useful to cope with big distances. And what we have in outer space is distance. So without nuclear solutions, nuclear reactor solutions, we won't be able to conquer space.
Okay, it's very interesting because I think in the past nuclear was not really an option for the space. Was it due to the safety reasons, or was it any other reason that we primarily tried to generate electricity from photovoltaic cells or photovoltaic panels in the space?
Because it's really cold outside. We have been using nuclear energy from the beginning in radioisotope thermoelectric generators form. So it gives the heat and also the electric power. For example, the Voyager uses it, but it has passed the limits of our solar system, but still working.
I see. Is there any technology to produce methane either on the moon or in the Mars when we have a longer space mission?
Yeah, I'm not really into technical reasons, but there is a solution to make methane on the surface on Mars with the help of CO2. And with special technology, they are able to make it over there. That's why it was the chosen one to use at the Starship missions, as the plan is to go with starships to Mars and there refuel and come home.
Oh, okay. So it's even possible, to use to have a methane, produce the methane locally, and then fuel the spaceships. What other gases play a role in space travel besides methane? I mean, we talked already about helium-3, but do you see any role of any other types of gases which might be an important issue?
Yeah, we just mentioned the carbon dioxide for methane production. We talked about the liquid oxygen, which is the main oxidizer in the case of kerosene, hydrogen, and methane as well. Liquid hydrogen, of course, because it's still one of the highest specific impulse fuel USD rockets. Nitrogen usually used for tank pressurization and orbital adjustments. Simple helium maintains pressure in cryogenic systems and helps to purge fuel tanks. And there are noble gases like xenon, which is the main propellant for ion thrusters used in deep space missions.
Oh, okay. So there's a wide variety of other
And
gases.
much more, yeah.
I see. Finally, let's talk a little bit about the investments, because you mentioned to me two investment vehicles which might be useful for those people who are interested in investments. Can you tell us a little bit about these 1X Space Innovators and iShares Global Airspace and Defense ETFs? What are these vehicles? How can a private person or a corporation invest into them, and what kind of investments does it include?
It is usually filled up with space startups or space-related startups, but I would say smaller companies, but which are ambitious enough to get in this asset, and who are already taking part in private-public partnerships. And I remember when I learned at the university that from $1, the space industry makes 8 within 10 years. This was the in the literature we got, but it seems like it works, because from April 7th, the big downturn of the stocks, for example, the Funnex Space Innovators gained plus 55%, if I remember right.
Yeah, I also checked it out, and they were quite good investments, especially the 1X Space Innovators. Although I realized that most of the stocks, except the biggest holding, is actually communication companies who might be also related to the space, as most of the communication is now running through satellites. So probably these companies are also involved in conquering space.
Absolutely, because what we have, we cannot imagine our life without satellite communication and with telecommunication devices. On the other hand, the other asset is mainly based on defense. What we mentioned, that maybe the prioritized area at the moment within the space industry, and that's where we are going to see big firms getting together within Europe as well to establish Europe's defense technologies. So that would be another big issue when it comes to stocks and assets.
Zsófia, do you have any final thoughts or any topics which you haven't touched, what you think is important in relation to this topic? Anything what you think would be important to express?
I would say that space is for the dreamers. And I encourage everyone to dream big, because what we can dream about, what we can imagine, believe me, we are able to manage to reach it and to bring it to life. So I encourage really everyone to be a dreamer, because this is how we can conquer space. And really the most important point to with our results, we can make terrestrial life better and more livable.
Zsófia, thank you very much. This was really a fascinating discussion. I believe we gave a lot to our listeners, and I myself learned a lot. So thanks very much, and yeah, I wish you good work in this area, and I wish that your dream would be fulfilled in the space as well. Thank you very much.
Thank you very much.